Welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it. This is chapter 6.2, which is on the law of cosines. All right, so consider the following. So consider the following triangle. And we're going to be looking at an oblique triangle. All right. And in this triangle, let's say that we have this line going straight down here, where that right there is a right angle. I'm going to call this angle A, angle B, and angle C. The opposite sides are side A, side B, and overall this is side C. This right here, this is the altitude. I'm going to call it H for the height. I will call this piece up to here, so this X, meaning that, well, if this entire thing is C and this piece is X, well, then this piece would just be the quantity of C minus X. All right, now let's get some information out of this. If we look at this first triangle right here, the one on the right, this right triangle, if I look at the Pythagorean theorem applied to this, I would get that a squared is equal to, well, C minus X squared plus H squared, and that's an equal sign. Right, that's from the Pythagorean theorem. So I have the square of the legs. The sum of the square of the legs is equal to the square of the hypotenuse. Now, let's look at this angle over here. And let's get some information out of there. So if I look at sine of that angle A, it would be opposite over hypotenuse. The opposite being this height here. So that's the opposite over hypotenuse, which really tells us that H is equal to B sine A. If I look at cosine of that angle, so cosine of A, that would be the adjacent over the hypotenuse. And in this triangle, the adjacent is X and the hypotenuse is B. So X over B. So that tells us that X is equal to B cosine A. Right? So applying these two into this equation, I would say, well, that gives us now that this is equal to C minus X, again, was B cosine A, so B cosine A squared, plus H was B sine A, so B sine A squared. And let's go ahead and expand this as much as possible. In here, I have a binomial being squared, so when that happens, I end up with C squared minus 2BC cosine squared, it's me just cosine A, plus B squared cosine A, cosine squared of A. That one is squared. That's just expanded this first one. The second one, that will give me B squared sine squared A. Now, at that point, I see that these last two terms, they both have a B squared, so we can factor that out of those two. And I end up with B squared times cosine squared A plus sine squared of A. And in here, this is one of the Pythagorean identities. This is just equal to 1, right? Sine squared plus cosine squared equals 1. So what we really get now is that this entire piece goes away. So we end up with, well, to put this in alphabetical order, A squared is equal to B squared plus C squared minus 2BC cosine of A. And that right there is the law of cosines. All right, so let's go ahead and talk about all the different law of cosines. all the different ways that the law of cosines can appear. So the law of cosines. Well, we just have the first one. A squared is equal to b squared plus c squared minus 2bc times cosine of a. Similarly, it can be shown that b squared is equal to a squared plus c squared minus 2ac cosine b, and that c squared is equal to a squared plus b squared minus 2ab cosine c. All right. Notice that in this last one, if c were equal to pi over 2, right? C being the angle, see? So if this were pi over 2, then cosine c would be 0. So 2 times a times b times 0 goes away, and we would end up with just the Pythagorean theorem, all right? A squared plus b squared equals c squared. That essentially tells us that the Pythagorean theorem is just a very specific case for the law of cosines, all right? Now, these can be rearranged to be able to work with just the angles here. So we can say here, if I solve for cosine A here, I would have that cosine of A is equal to a squared minus b squared minus c squared all over negative 2bc. But we don't really like to have that negative on the bottom, so we can rewrite this as c squared minus a squared minus b squared. Hold on, I wrote that wrong. B squared plus c squared minus a squared. There we go. B squared plus c squared minus a squared over 2bc. Similarly, I can rewrite cosine b. So that's cosine of b as a squared plus c squared minus b squared over 2ac. And cosine c as a squared plus b squared minus c squared, a squared plus b squared minus c squared over 2ab. All right. So now that we have this, let's go ahead and do some examples. All right. So again, these are all the different ways that the law of cosines can appear. All right. So now let's say that we have the following question. So it says, find the angles of the triangle below. Find the angles of the triangle below. So let's say that we have a triangle like this. All right. And in here, I'm going to say, well, this is A, this is B, this is C. All right. Let's say that this is equal to 14 feet. Here, B would be equal to 8 feet. And C would be equal to 19 feet. And the question here is, what are the angles of this triangle? All right. Notice here that what we're given, the information that we're given here is side, side, side. We're just given the sides. We're not given any of the angles. So because we're not given any of the angles, we cannot use the law of sines that we learned in the previous section, right? The law of sines is not applicable here. So, well, since we need to find angles, I'm going to use one of these, all right? And let's say, I'm just going to go ahead and copy one of these so I don't have to rewrite it. So let's solve for angle A. So I'm going to use this here. All right. And let's just highlight that. Notice that here, if I want to be looking for angle A, what I need to do is actually take cosine inverse of both sides. So that angle A is cosine inverse of b squared plus c squared minus a squared over 2bc. All right. So now let's go ahead and apply that here. So that's going to tell us that angle A is equal to cosine inverse of b squared, well, b was 8, so 8 squared plus c squared, so 19 squared, minus a squared, which was 14. So 14 squared. All of this over 2 times b times c, right? And at that point, what we need to do is essentially plug this into the calculator, but let's simplify a little bit. So I'm going to have here cosine inverse of, so we have 8 squared, which is 64, plus 19 squared, which is 361, minus 14 squared, which is 196. All of this over 2 times 8 times 19. Well, 2 times 8 is 16, times 19 is 304. At that point, we get, well, we need to add that up. So we have 64 plus 361 minus 196, giving us 229 over 304. And that's what we plug into the calculator. Cosine inverse of 229 divided by 304. Make sure you're in degree mode so you can answer this question in degrees. This gives us 41 point, I'm going to round it to 3 decimal places. No, I guess just 2 decimal places. 41.12. It's really 0.123868661 or something like that. But we'll leave it as 41.12 degrees. All right. Now, the next thing we need to do here is figure out another angle. So far we've got angle A. We got to figure out all the angles. So if I do, let's do the same thing, but for angle B. So I'm going to copy this piece right here, and we'll apply it. So here we go. Paste. And just like before, I'm going to solve for angle B here. So angle B would be cosine inverse of a squared plus c squared minus b squared over 2ac. And in this case, that means that b is going to be equal to cosine inverse of, well, let's see. A was 14, b was 8. So A was 14, B was 8, and what was C? C was 19. Okay, so we've got 19 squared there, all over 2 times A. I forgot which one was A. A is 14, so 14 times C, which is 19. There we go. All right, and I mean in here, notice that we're working with pretty much the same numbers, just in a different order up here. So we're gonna get cosine inverse of, well, 14 squared, that was 196, plus 19 squared, that was 361, minus 8 squared, which is 64. On the bottom, we've got 2 times 14 times 19. That gives us 532. And now we've got cosine inverse of, well, 196 plus 361 minus 64 gives us 493. So 493 over 532. And if we take cosine inverse of 493 over 532, that would get us 22.08 approximately. So I'm rounding to just 2 decimal places with these answers, but that's what we have there. All right. At that point, well, we've got 2 angles already, so we really can figure out the third angle, right? Because we know that the sum of all 3 angles is supposed to be 180 degrees. But for the sake of practice here, let's go ahead and use the law of cosines to figure out angle C. All right. So let's go ahead and paste that here. And again, I'll rewrite that in blue so that I can solve for the angle C. And angle C would be cosine inverse of a squared plus b squared minus c squared over 2ab, right? In this case, what does that mean? That means that we have the angle C is equal to cosine inverse of a squared, right? So that's going to be 14 squared, and that's a square, plus b squared. B was 8, so we have 8 squared, minus 19 squared, that's a squared. All of this over 2 times 14 times 8, which gives us now that we have cosine inverse of, well, 14 squared, we already know that's 196, 8 squared is 64, and 19 squared is 361, and we have this all over 2 times 14 times 8. So 2 times 8 is 16, and then that times 14 is 224. So now we get, well, we need to do cosine inverse of this, but we have 186 plus 64 minus 361 gives us negative 101. We have that over 224. So cosine inverse of negative 101 divided by 224 gives us 116.80 or so. All right, and if we check our work here, we can check to make sure that all these kind of add up to 180 degrees, right? So our check, we can say, what were the first angles? It was 41.12 and 22 point, so 41.12 degrees plus 22.08 degrees plus 116.8 degrees. Well, what does that give us? We have 41.12 plus 22.08 plus 116.8. Look at that. 180 degrees exactly. So our rounding off worked out. Sometimes, depending on how you round this off, you might be slightly off on this 180. You might have like a slight decimal above or below, but this ended up working out nicely the way that we rounded it. All right. Let's do another one. So example B. So let's say that I said that so we have side A, side B, and side C, and excuse me. All right, so we were saying that A is 12, B is 6, and let's make C 8, right? So let's see what this triangle looks like. So we have down here is angle A, angle B, angle C. Across from A, we have side A being 12, side B across from angle B is 6, and side C across from angle C is equal to 8. And again, we want to find all the angles here, all right? So let's go ahead and start this, but I'm gonna go ahead and just copy some information from here so that we don't have to rewrite too much. So if we start with angle A there, so angle A is equal to that, which means then that A is equal to cosine inverse of B squared, so that's 36, plus C squared, that's 64, minus A squared, which is, well, 12 squared, which is 144, over 2 times B times C. 2 times 6 is 12. 12 times 8 is 72. But no. 12 times 8 is 96. Sorry. 96. There we go. 12 times 10 is, 8 times 10 is 80, and then add 16. All right. So now, in here, well, 36 plus 64 is 100, minus 44 is negative 44. So we end up with cosine inverse of negative 44 over 96. So when we plug that into the calculator, cosine inverse of negative 44 over 96 gives us 117. So this is equal to 117 point, and again, I'll round to 2 decimal places. So 117.28 degrees. For angle B, let me go ahead and copy that formula again. just so that I don't have to rewrite it. So for angle B, well, this is going to give us that angle B is cosine inverse of a squared. Remember, a was 140. A was 12, so a squared is 144 plus c squared, which is going to be 64, minus b squared, which is 36. All of this over 2 times a times c. So 2 times a times c. So 2 times 12 is 24, and then that times c, which is 8, ends up being 192. And now 144 plus 64 minus 36 gives us 172. So in here we have cosine inverse of 172 over 192. All right, and if we plug that into the calculator, cosine inverse of 172 divided by 192, that gives us 26.38 degrees. So 26.38 degrees. And lastly, let's look at angle C, but again, let's just copy and paste this part so that we can just go ahead and use it. So there's angle C. So I'm going to say now that the angle C means that it's cosine inverse of a squared. A was 12, so 144, plus b squared, b was 6, so we end up with plus 36, minus c squared, c was 8, so we end up with minus 64, over 2 times 12 times 6. Well, 2 times 6 is 12, and 12 times 12 is 144. Right, so now we've got 144 plus 36 minus 64, right? That's going to give us 116. So I've got cosine inverse of 116 over 144. And then when we go ahead and take the cosine inverse of 116 divided by 144, it gives us 36.33. 34 really. 36.34 degrees. All right. And now we can check by adding all these angles to see how off we might be on our estimation. So we're going to say 117.28 degrees plus 26.38 degrees plus 36.34 degrees. Let's see what that gives us. So we've got 117.28 plus 26.38 plus 36.34. That gives me again exactly 180. So I round that off to 2 decimal places perfectly here. All right. So there you go. That's really just the law of cosines in general. Now there is another way to apply this. Notice again in here that I gave you side, side, side. All right. So just like in the first example, I just gave you all 3 sides. Now it is possible to give 2 sides and an angle and still not be able to use the law of sines. So let's check out that version. So let's do example D. Let's say that I have this triangle, and again I'll just draw some generic oblique triangle here and label the angles in the same way that we have been. Now this angle here, let's say it's 25 degrees. This side over here is going to be side A. Side B, let's say that that's 9. And side C, let's say that that's 12. All right. Now, in here, it's not possible to use the law of sines. All right. Well, first, let's look at what we're given. I have a side, they include an angle, and then another. So I have 2 sides and the angle in between them, which makes this an SAS information, side angle side. All right. Now, the reason we can't use the law of sines, and I'll remind you of what the law of sines was, sine A over A is equal to sine B over B is equal to sine C over C, is because, well, no matter how I pair these, I'm going to miss too much information, right? So here, if I pair up this angle with that side, all right, so I've got an angle and I'm missing a side. That's not too bad. but no matter which one I pair it with, I'm missing too much information to be able to work with this law of sines. So we're not going to be using the law of sines here. We're going to be using the law of cosines, all right? And the very first thing that I'm going to solve for here is, let's solve for side A, all right? If you recall from before, we have that a squared is equal to b squared plus c squared minus 2bc cosine of angle A. So in this case, and perhaps I'll highlight that in blue to be the formula that we're using. So in this case, we're going to get that, well, b squared, b is 9, so we end up with 81, and that's an 8. 81 plus c squared, c is 12, so 144, minus 2 times 9 times 12 times cosine of angle A. And perhaps I should have just plugged this in as just the general formula. So we have 9 squared and 12 squared. All right, well, we know what 9 squared is. 9 squared, we said it was 81, and 12 squared is 144. But now, 2 times 9 times 12, so that's 18 times 12, which gives us 216. So we end up with 216 times cosine of 25 degrees. At that point, if we plug everything into the calculator, 81 plus 144, well, that's 225. So I've got 225 minus 216 cosine of 25 degrees. And that's what I'm going to plug into the calculator. 225 minus 216 times cosine of 25 degrees. And make sure your calculator is in degree mode. And this gives us 29.237. Well, let's round up to 2 decimal places. So 29.24. All right. That would be a squared. But I don't care about a squared. I care about a. Right? So since a squared is equal to 29.24, that tells me that a will be the square root of that. So the square root of 29.24 ends up being 5.40, 5.41 really. So it's 5.4074, but I've been rounding everything to 2 decimal places, so let's go ahead and just do 5.41. All right. Now we've got that side, so 5.41. So this is approximately 5.41. Now we can figure out all the other angles, right? Because I can use the law of sines now if I wanted to. Or now that I've got all the sides, I can continue to use the law of cosines. I'll continue to use the law of cosines just to get practice here. All right, so we need angle C and angle B. Let me go ahead and just copy these right here, just so that I don't have to write too much. And here we go. So, all right, now, this tells us now that B is going to be cosine inverse of a squared. Well, we know what a squared was, 29.24, plus c squared. What was c? C was 12, so 12 squared is 144, minus b squared. B was 9, so b squared would be 81, over 2 times a times c. So I'm going to do 2 times 5.41 times, hold on, 2 times 5.41 times, so what was c? C was 12. So 2 times 5.41 times 12 gives me 129.84. And if I plug, well, let's do that sum on the top. 29.24 plus 144 plus minus 81 gives us 92.24. So I've got cosine inverse of 92.24 over 129.84. And I've got cosine inverse of 92.24 divided by 129.84. Make sure you are in degrees. And the calculator tells me this is 44.73, and this is in degrees, right? So that was angle B, 44.73. Angle C would be, well, cosine inverse of A squared, which we already know to be 29.24, plus B squared. B was 81, so B was 9, so B squared is 81, minus C squared. C was 12, so C squared is 144, all over 2AB. So that's 2 times 5.41 times 9, right? Because B was 9. So this gives me 97.38, which means if I add up the numerator, so 29.24 plus 81 minus 144 gives me negative 33.76, and we have this over 97.38. So we're going to do cosine inverse of negative 33.76 divided by 97.38. And that gives me 110.28 degrees. Now, is this 100% accurate? Well, let's see. Let's see what the angles were. So we had 25. So this will check. Angle A was 25. Plus angle B is 44.73. Plus angle C is 110.28. So let's see. 25 plus 44.73 plus 110.28 gives me, oh, hold on, I plugged it into the calculator wrong. All right, gives me 180.01. So 180.01 degrees. Let's write that better. And obviously, that's not fully correct, right? Because in a triangle, you're not supposed to have more than 180 degrees, which tells us that we have a slight error in our rounding. That's not too much of an issue though, because it's only at 0.01. All right. But again, the idea here is that when we're given side angle side, we cannot use the law of sines. So we had to work around it somehow, and we do it with the law of cosines. After we have this side A, we could have worked with the law of sines instead of working with the law of cosines, but I wanted us to get more practice with the law of cosines. All right. Let's do a word problem. All right. So that was example, what was that? D. So E. And all right. So hold on. Now that I think about it, I don't think there was an example C. Was there? Nope. So let's change this to example C, which means we are at example D. All right. So the word problem. So it says a ship travels 40 miles due east and then changes direction towards northeast. All right. After traveling 30 miles, in the new direction, the ship is 56 miles from the point of departure, from its point of departure. Describe the bearing from point B to point C. And here when we're saying point B and point C, well, let me give you the diagram here so you see exactly what we're talking about. So we're going to start here. That's where the ship started, right? And then maybe let me make more space. So down here. All right, cool. So a ship travels 40 miles due east. All right, so let's remember what that means. This is north, south. That's not south. What? South, east, west. So it travels 40 miles due east. So there it is, 40 miles due east. And after that, it changes direction towards northeast. Now, northeast could be anywhere in between here, right? So I'm just going to do some generic angle towards northeast. And after traveling 30 miles, so let's label this. So first, this was 40 miles. Now it's traveled 30 miles. And the thing is that now we know that after traveling 30 miles, the ship is 56 miles from its original point of departure. So that that distance is going to be 56 miles. In here, when it says describe the bearing from point B to point C, well, let's say that this is point A, this is point B, point C. The question here is, well, the ship was going straight out that way. Now it's going this way, right? So the question is really here, what is this angle and in what direction? All right. So let's go ahead and do this. Now, notice here that this angle is very much paired up with this angle over here, because we have that this straight line would have to be 180 degrees. So if we can figure out angle B, we can figure out what this angle over here is. So let's go ahead and do that. So if, there we go, that was still copied, so I just pasted it nice. So angle B. Let me erase the information here for angle C. So we're looking for angle B. So in this case, we're going to say, well, that's going to be, angle B is going to be cosine inverse of A squared. A is about, side A is across angle A. So we've got 30 squared plus C squared. C was across angle C, so 40, minus B squared. B was 56, so minus 56 squared. All of this over 2 times A times C. A is 30, C is 40. All right. So let's see what that gives us. And I'm gonna go ahead and just write 30 squared plus 40 squared minus 56 squared. That gives me negative 636. And now 2 times 30 times 40, it gives us 2400, which if I plug that into the calculator, and then with cosine inverse of negative 636 divided by 2400, which becomes 105.37. 105.37. It's really 30.3669528, but 0.37 is a nice round off number. So in general, 2 decimal places is what I've been doing. All right, cool. So the thing about that is that what we just found here, again, that's this angle. But I need this angle over here. So what we're going to say here is, well, 180 degrees. So perhaps I'll call this theta. So in there, that theta is going to be 180 degrees minus 105.37 degrees, right? And 180 minus 135.07, not 135, 105.37, gives us 74.93 degrees. All right. So now let's go ahead and answer the question, because it said describe the bearing from point B to point C. Alright, so when they say describe the bearing from point B to point C, they're really saying, alright, it was heading in some direction, right? What happened after it was heading in that direction? So we were heading east, and then we changed by 74.93 degrees towards the north. Alright, so when we're talking about bearings, we're saying what direction were we at, what angle did we change by, and towards what direction. Alright, so that's why we have this as it was going east, it changed by that angle, and towards the north. Right? Cool. So that's our answer. Maybe I'll put that at the very end because that is our final answer here. So the bearings, or the bearing, which way it's bearing, it's that way. All right. Let's talk about something called Heron's formula. All right. Now, Heron's formula is a formula for the area of a triangle, for any triangle. All right. So in the last section, we spoke about how to find the area of a triangle if you're given some angle, right? Of any oblique triangle. In this case, we're gonna talk about using the area or finding the area of a triangle by only knowing the lengths of its sides. So in general, let's say let S be the semi-perimeter of a triangle. That is, that S is equal to the sum of the sides of the triangle divided by 2. Then, the area of the triangle is the square root of S times S minus A times S minus B times S minus C. Alright, so that is how we find the area of a triangle using Heron's formula. So let's go ahead and do one. Alright, so let's say, what am I at now? E, maybe? Yeah, E. Let's say that a triangle has sides of 5, 9, and 8 meters. 5 meters, 9 meters, and 8 meters. Find the area. Alright, so I mean here it doesn't really matter too much what it looks like, but I'll go ahead and draw a visual. So we've got, let's say that this right here is 9 meters, let's say that this right here is 8 meters, and this right here is 5 meters. And we want to figure out the area of this triangle. Well, we've got a way to do it. We've got Heron's formula. Alright, so what we're going to start with is finding the semi-perimeter. So the semi-perimeter, remember, was the perimeter divided by 2. So in this case, it's going to be, let's say, so 5 plus 8 plus 9 divided by 2. 9 plus 8 is 17. 17 plus 5 is 22. 20, so we have 22 over 2, which gives us 11. So the semi-perimeter here is 11. Now, let's go ahead and find the area. So the area is going to be, well, the square root of, I'll remind you the formula, S times S minus A times S minus B times S minus C, which means in this case, 11 times 11 minus 5 times 11 minus 8 times 11 minus 9. At that point, doing all those, we end up with, well, 11 minus 5 is 6. 11 minus 8 is 3. 11 minus 9 is 2. 2 times 3 is 6. 6 times 6 is 36. And 36 times 11 is 396. So I end up with the square root of 396. And if I take the square root of 396, I end up with 19.89. Well, that's so 19.89974, which I'm just gonna say that this is approximately 19.90, and this would be in square meters. Excuse me. All right, so that is the end of this section 6.2. But again, in here, we were able to find the area of this triangle without knowing any angles. And it's not a right triangle, so we wouldn't be able to use the regular 1/2 base times height. We also are not given the height at any point, so we can't use that. In any case, like I said, that is the end of 6.2.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.